Hi everyone, welcome to Group 4. Today we are going to present about geometry and arithmetic series. Before we start, I would like to introduce our group member. First is Abigail Su Guanrou, Cha Kai Chen, Justin, Pan Sen San, and Tarnita.
First of all, we have to know the definition of series. What is a series? A series is what you get when you add up all the terms of a sequence. So we have two types of series, arithmetic series and geometric series. So what is an arithmetic series? We can define an arithmetic series as a sequence where the differences between every two consecutive terms are the same. The first term is obtained by adding a fixed number to its previous term. So we have two types of arithmetic series formulas. We have an is equal to a1 plus n minus 1 times d, where an is equal to the nth term, a1 is the first term, and d is the common difference. The second formula is related to the sum of first n terms of an arithmetic series when the first and the last terms are known is given as Sn is equal to n times a1 plus an over 2. Where S is equal to the sum of the first n terms, an is equal to the last terms, and a1 is equal to the first term, and n is the number of terms being added.
Geometry series is a series where every term is a counter ratio to its preceding term. In order to get the next term in the geometry progression, we have to multiply with a fixed term known as common ratio. Every time, and if we want to find the preceding term of progression, we just have to divide the term with the same common ratio. To find the m term in the geometric series, we require the first term and the same common ratio. Where a is the first term, r is the common ratio, and m is the term we want to find. The number of terms in a geometric progression is finite. Then the sum of the geometric series is calculated by the formula. However, if the number of terms of a geometric series is infinite, then the sum of the geometric series formula is calculated by. Here is our problem background. During the morning, Xiaomin decided to eat bread for breakfast. He noticed that the bread he bought yesterday had become moldy. After research, he found out that the number of bacteria after 4 and 8 hours is 1,000 and 100,000 respectively. If the number of bacteria start from 1, by using the formula of sum of geometric series, find the total number of fungi on the bread after 1 day. The fact is the number of bacteria increase in time. Bacteria grow rapidly in the bread. Learning issue. What formula can be used to solve the problem? How many bacteria reproduce in the bread after 24 hours? The problem created was based on the total number of bacteria that were reproduced in the bread after 1 day. This problem can be linked with the geometric series. Next, the purpose of this problem is to remind us one of the more important applications of mathematical series, which is in Chapter 3.
So, based on the question, we can identify the time frames, namely the 4th hour and the 8th hour, as well as the amount of bacteria produced in said time frame, which are 1,000 and 100,000 respectively. Now what we need to do is find the first term of the progression, denoted by the letter A. And we can achieve that by first finding the common ratio and comparing them between the time frames. After calculation and comparison, we can see that the first term of the progression is the 2nd hour.
Now, to find the n term, an is given by the question, which is equal to 1 day, and in other words, we can say it is equal to 24 hours. As we know just now, the first term a equals to 2 and the common ratio r equals to 2 as well. Now, in order to find the n value, we have to use the method of logarithm. We substitute log base 10 at both sides of our equation. As a result, we could get n minus 1 equals to 3.58 and n equals to 4.58, which approximately equals to 5.
Now, step 3. To calculate the amount of bacteria after 24 hours. At first, as we know, our first term is 10, second term is 1,000, and third term is 100,000, and so on. By using the data above, we are able to get the common ratio R by dividing the second term and the first term, which is 100. Now, we may use the sum of the geometric sequence formula to calculate the total number of bacteria, which is Sn equal to 10 bracket 100 power 5 minus 1 bracket over 100 minus 1. And now we get a final answer which is equal to 1,10,101,010.